to get going. Got a couple things today. Let's take a peek here at our schedule. So this is officially week 6, really week 5 of the course of our 14 actual meetings here as we go. So we are a third of the way through, believe it or not, which is pretty, or by the end of tonight we'll be more than a third. Well, before we start, we're a little less than a third, but we're cruising along. So we got Project 2 coming up. I'm not muted, am I? Okay, good. Project 2 is coming up due next week. And then next week we'll talk about Project 3. The plan for Project 3, again, we'll just pretend these weeks don't exist where we have holidays. It'll be due on 7/11, and then we'll meet for midterm review, where the only thing I have, I'm sorry, I can pull it up a little higher here. For midterm review, the only thing I have planned is I'll give you a sample midterm on 6/27, and then on 7/11, I'll go over answers to it. So you've got some time to practice it yourself, and then if you had questions about it, we can meet and do that. You don't have to take the exam with me sitting in front of me. I don't like timed exams. I think that is an awful way to measure if someone can actually do something. That being said, if you have the whole week to do it, it'll be a little harder than it would have been if you were to sit and take it for like 2 hours. So there's a bit of a trade-off there. But generally, that's a bit more fair way to measure these sort of things. On the quiet side, let me see. I don't think I had any filters on this. That's what happened last, was it quiet last time? I'm trying to remember now. Properties, nope. I can gain the volume here. Might just go up a little bit and see if that helps at all. I don't know, take it up 3 more decibels. Is that any better if I go up 3 more? Okay. I don't know. Probably better louder than not, right? We'll take it up to 5. How's that with a gain of 5? Is that any better, folks?
Sounds fine for my headphones.
Okay, so on your, okay, because you can hear it through your headphones. Cool. I'll leave it at 5 and.
Before you start messing with volume.
Oh, okay. That's the only part that's hard because I don't hear what it sounds like until after I look at the recordings. Yeah, so for the midterm, it'll be half quiz questions. Like I'm literally going to take them from the quizzes, and then half long answer style. Please write some code that does this, but not large like a project. Just like, hey, do one small thing here, and that'll be the midterm. So you'll have until 7/18 to turn that one in.
Yeah. So this midterm exam, is it in D2L?
Yeah, it'll be a quiz in D2L like the other quizzes, but it'll have some long answer sections where you can just copy paste some code in.
Yeah. Okay.
Yep.
And then even in D2L means we kind of have some time limitation maximum.
No. So I won't time, just like the weekly quizzes, you'll have a due date. You can open and close and come back to it. It'll be the same way with the midterm.
Oh, okay.
So I think timed exams are awful, and it just like the chapter quizzes. Yeah.
Oh, I didn't even know you could do that.
Well,
Yeah,
mine you can.
Oh,
Yeah. So it's unlike, so it's not a timed. Once you hit start, you have 2 hours to hit submit. I think that's a terrible way to measure if people can do things. So yeah, it'll be untimed. If you want to sit and take it in class, that's perfectly fine. I'm happy to watch you take it. Or you've got all week to start it, come back to it, start it, come back to it, do whatever you need here. And again, it's not worth very much overall in terms of the overall score here. 10%, so just as much as your labs or quizzes combined. So I don't like exams, so I care if you can write code. So your projects and final projects are much more heavily weighted than anything else here. And that's what I'm looking for. So then we'll do that and we'll come back, pick up the last individual project, Project 4. That'll be due August 1st, and then all of August we will be working on the final project here. Again, hopefully in pairs. We're still a little crazy for that, so I'm not going to require it. But hopefully if you found somebody you can partner up with by then, you'll end up with a better product and a better experience, because really writing code all by yourself without working with anyone else is really lonely. And you can't bounce ideas off of anybody. So working with a partner is fantastic. and then it generally works out to be the same amount of work because partners have to coordinate and collaborate and figure out who's doing what and talk to each other. So the amount of effort is about the same as just someone doing it themselves. It is generally how I look at that. And that's it for the semester. So I know, a third of the way there, and we'll keep on cruising. All right, so there is a quiz from last chapter. I did post it a little bit late, so if you want a little extra time on it, that's perfectly fine. I'll take it late. It says due tonight, but if you want to do it tomorrow or the day after, that's perfectly fine because I posted it late, so that's on me. And we'll just try and keep up with. Usually I do them when I get home, but I forgot, so I had other things going on when I got home. So we'll keep up with the quizzes. So we're on to chapter 5 this week. I want to talk about the lab here. So a couple things I noticed when people start working with functions. Two things usually pop out here is that functions can either return values or not return values. So this first affirmation generator was not returning any values. All it did was print. It didn't even have any arguments. So just call your affirmation generator and it will do something. One of 5 different things over and over and over. So this one's really basic, but the quadratic equation intercept finder accepts values, has parameters, has arguments, right? And it returns a value or a string saying they don't exist. So we're going to return something. So just like we use our other functions, right? We need to be able to use this to give us back values, and we need to hand it values. Like we've rounded before, we've done min, we've done max. Actually, we didn't do mins and maxes, did we? Well, yeah. So if you don't return a value, you can't assign it to anything. We looked at that a little bit last week. Let me fire up PyCharm here. I'm going to take a look at this lab and talk a little more about it here because we're going to keep using functions from here on out. So we never get to forget them here. So that was our. So this was lab 3, right? We'll do all this lab 3. All right. Zoom that in a little bit. So to define a function, right, we use the def keyword for define. This is our affirmation generator. And if we don't need any arguments, it's just open and close parentheses. Did I spell it wrong? Oh, I did. Generator. And even affirmation is wrong? Is that 2 Fs? Okay, there we go. So we need to randomly pick a number 1 to 5. Right, so we can do that. So this will be just a number here. Is random dot randint. Right, and it should import random for us. If it lights up red, we can type this line in ourselves or let PyCharm do it. We want 1 to 5. Any range of 5 is fine. 0 to 4 is 5 values. And any way you wanted to do it is okay here. And then we can just say, hey, if number is equal to 1, the space there, then let's return, I'm sorry, let's just print, right? We're not returning anything. So we can just come up with some affirmations. Affirmation generator. See if we can't find anything good. That's taking a long time to load. All right, I like this one. The point of life is balance, not perfection. Sure. Elif, the number is 2. What do we got here? And we should probably cite our source here, right? Where we're getting our affirmations from. I don't care if you did this or not. Like that's okay. But I just want to show good practice here. Let's see. I'm capable of overcoming anything. Don't know if that's always true, but we could try it. Number is 3. I always pick myself back up. All right, I left number is 4. Another one. And then the last one here, we could just be an else, right? We don't even need to check if it's anything else, right? You could say if it's 5, go for it. But our case, we know if it's not a 1, 2, 3, or 4, it should be a 5. Here. And there we go. So now we have our affirmation generator. So if we want to use it here, oh, it wants one more space here. If we want to use it, we can just call the affirmation generator. And it will print our affirmation. So if we want to get a couple of them, right, probably do it a couple times. And it's random. Hopefully we'll get all 5 here at some point, but we get a couple different ones here. Right, so it seems to be working. So again, this one doesn't return any values. All it does is print. So we just put a name to the code here. And then if I want to do it more than once, right, I don't need to have the same code. So if you were to try and assign something like a result, right, that's when you get back that none. Because and it's even telling us or warning us here that the function doesn't return anything. PyCharm can tell that there is no return, so you're not going to get any result back. It's going to be none. There's nothing, or null if you're familiar with other languages. We get nothing. Okay, so we don't need the result. All right, so that's the first one. Again, that's just basic. Doesn't even take any arguments. It just does something, puts a name to it. The quadratic equation intercept finder is much more interesting here. Let me see if I can bring that up a little bit. Sorry. So this one needs to accept values for a, b, and c that fit into the quadratic formula, ax squared plus bx plus c equals 0. So we're going to write a function that accepts values for a, b, and c. Now, generally, I hate the letters a, b, and c for variable names, but that's literally the math equation. So we might be able to come up with slightly better names if we tried really hard, but that fits in the math equation. So we just say a, b, and c. Right? So my function will accept arguments. Your functions, generally, here, if they're accepting arguments, don't go ask the user to enter them. So a couple people said they wrote a function, it took an a, b, and c, and then said a equals an input of enter a value for a. Right? That's duplicating your effort. Right? If you are given a value for a, that's your value for a. You don't need to go ask for it. Now, if your function's job is to go and ask the user for input, sure, perfectly fine. But again, generally what we try and do with our functions, because we want our code to be reusable, is most of the time input never belongs in functions. And I'll show you a couple examples where that's not true, but generally you want to pass arguments to your functions if they need values to work on, because that way you can use it in a web application or a console application or a graphical user interface application, or I really should find out if you can run Python on mobile. We should just Google that, but you know, mobile application is the other general go-to. Hey, White Paladin, thanks for joining along, my friend. So yeah, don't do this, right? Just use the value passed here. And by passed, I mean that you have to provide it with an a. So I can't call this function, quadratic equation intercept finder, without giving it an a, b, and c. Right? It's no good here. Let me give this a run. Oh, sorry, this one needs some code here. Just say b equals 1. Or just want to see if it'll run here real quick. Right, and you get missing required positional arguments. Right, when we talked about positional arguments, it's the first thing is the first one. That's the first position. The second position, the third position. We don't have to name them. If you wanted to, you could say c equals something. Right, you could name them. Use your named parameters, which is not too bad, but this is pretty good here. All right. So for the quadratic equation intercept finder, we have to do a couple things. If b squared minus 4ac is negative, there are no intercepts. We should return a string saying they don't exist. Like there are no intercepts. So let's calculate it. So this is also known as the determinant, if you like math words. If you don't, it doesn't matter at all. That's okay. But I can call the determinant. Determinant is, now b squared, you can't use the operator here. This is not going to do what you expect it to do. It is a bitwise or shift operator. It is not exponents. You'll get some really funky stuff here. Honestly, I don't even know what bitwise operations do. They confuse me. But it's not a normal math thing, okay? So to use to the power of, you can use 2 multiplication signs or the math.pow function. Hector, my friend, thank you so much for donating those bits to the Student Scholarship Fund over the University of Michigan Dearborn College of Engineering and Computer Science. Hey, that wasn't even too bad this time. So b squared minus, now if you just say 4 times a times c, this should work because your order of operations, right? You'll get your multiplication first, and then we'll do the subtraction. It's okay. I'm going to put some parentheses in that are redundant because it makes me happy, right? I know they're redundant. I know order of operations will work here, but like I want to make sure that this happens first. So I guess you can probably use too many parentheses, but let's just use them to clarify it. Again, the code's for people. So it'll be a visual cue to you that this happens first. Okay? And then we can check, hey, if the determinant is less than 0, we're going to return there are no intercepts. Right? You can't do it. There are none. So this quadratic equation is the little parabola, this little loopy looking thing. So if it doesn't cross through the x-axis, there are no intercepts. There's nothing to find. Otherwise then, right? Then we have a first intercept and a second intercept. It's negative b plus the square root of b squared minus 4ac divided by 2a, and negative b minus the square root of b squared minus 4ac, both divided by 2a. It's not the kind of thing you need to memorize. It's still in my head from my 8th grade math class, because that's the kind of thing that takes up space in my brain, because I don't know why. But we can not quite copy paste these in here, right? It's not going to work exactly like we expect. Okay? So negative b, okay, plus the square root of, so that's math dot square root, b squared minus 4ac. Now we already have this thing called the determinant, so we could save a little bit of time here and just drop that in, right? Math dot square root. And then, let's see, we want the whole thing here then divided by 2a. Math? Why does it not like my math? Oh, we didn't import math. Import math. There we go. So if we import math, we can go and use math. Excuse me. Now, it doesn't like all my extra spacing. I like the spacing, but PyCharm hates it, so I will get rid of it. Determinant divided by 2. Now what is it? Okay, now it's happier there. So if it's not negative, we can take the square root of it. If it's negative, you can't take the square root of it. That's why this whole thing fails. Right? When a function finds a return, it stops. So if this was true, this code will never run. So you don't even really need an else block here, because if this was true, you're never getting down to these lines. Right? If it's not true, then we just keep on going. It doesn't even need to be in an else block, because the code will just keep running here. So you could have it in an else if you wanted, but that's a little bit redundant at that point. And then 2, this was actually 2 times a here. Right? I'm sorry, so I didn't copy paste right. That's why I had those extra a's. I was wondering about that. 2a. Now, this one here is really bad, because order of operations says you do multiplication and division from left to right. It will divide first, and then it will multiply. Right? That's order of operations from left to right, because multiplication and division have the same order of precedence. So this one definitely needs parentheses to be 2 times a. Again, those spaces. Spaces, sure. Okay, so definitely needed here, just helpful up here. Okay, then if we wanted to, right, we figured this out, now we can return the intercepts. So we have x-intercepts, intercepts of, plus the first x-intercept, plus the second x-intercept, sure. We're returning it as a string. It's not numeric values. It'd be difficult for someone to use, so this is not ideal, but we haven't really talked about how to use multiple values, so it's okay. So you might see some people say just return first x-intercept, return, goodness, the first first x-intercept. Why? I won't type ahead. Comma, the second x-intercept. Technically, you can do this in Python. What it's doing here, for those who are curious, it's actually turning it essentially into a list, or really a tuple, which we'll get into later. So we can essentially return them like this, but the parentheses are redundant. And it doesn't mean a whole lot till we get to a couple later chapters here, but this is valid, and then it will give you the 2 numeric values, not it as a string here. Again, for our purposes, we don't really care here. We're not really using these numeric values at all. All we're going to do is print it to the screen. Okay, but you could do something like that. Yeah.
What are the addition, the plus marks around first intercept and second intercept?
The plus marks here,
Above that.
above here.
Yeah, what are those?
So I'm taking a string. So this is my string, x-intercepts of, and it's going to concatenate a value to it. Right? Because if Python sees a string and a number, it says, oh, if you want to plus them together, you can't do arithmetic here. I think this one will work. Is it going to fail? Now I'm confused here. But let's try it. So give it some values. So if we do 1, and then we do 2, and I think -4, I think this works. Because a negative value in here will mean we're going to add, right? Subtracting it means you add, so it should be okay here, I think. And then it's going to give me a result here. So my result can equal what I get back here. And then I can print my result. Right? Because I'm going to return something. So I'm either going to get this line or this line. Let's give it a shot. Nope, I'm sorry. I have to add string here. Python is not smart enough here. So I have to tell it it's a string of this. Then it will concatenate the strings together for me here. All right, let's try that again. So here we go. We get some, oh, sure. Those look like two intercepts. 1.23 and negative 3.2, sure. Something in there. Okay, we can do that. So I think if we do 0 here, that might be a little cleaner. Yeah, there we go. So if that's 0, then we get 2 and negative 2. That's a lot cleaner numbers here for our equations. But again, the thing to focus on here, we are passing it parameters. Its job is not to ask for the input because it has them as parameters. And most of the time we want our functions not to deal with asking for input because then our function can be used anywhere we want it to be. Okay, and then we return values that can be then assigned to a variable and then used somewhere else. Right, just like we did with these math functions, right? Like math.square root gives you a value back. We're not saving it anywhere. We could, if we wanted to save it somewhere. We could save like one more line here, not have to do this arithmetic twice. If we wanted to save it off, but okay. Any other thoughts, questions, concerns about the lab? We'll just practice writing functions. We'll do more functions. Yeah, Helrutan, it just returns a none. Yeah, so we talked about if you don't return anything, you'd get none or null. It's just ugly. So there's nothing to do with it here for these types that don't have a return statement. So it's the same as saying return none with the capital. This is redundant at this point, though. Python will do that for you. That's redundant. Redundant. Can't spell, I'm sorry. All right, cool. So let me save that and get that a commit here. We want 2131. This is lab 3. I don't think I need, I don't know. Sure. If these idea files change, it's fine. It's lab 3. I don't know what I changed here, but that's okay. Cool. So we got that one. So let me start up a new project here for chapter 5. So chapter 5 is going to be about iterations, or most of the time we call them loops. How we can do something over and over and over and over again, as many times as we want it to happen. So when we did the number guessing game, we did that a while ago, right? We said guess a number, and we said if it was too high or too low or just right. Did we do that like 2 or 3 weeks ago? It might have been before Memorial Day. Did we guess a number? We didn't guess a number? Okay, well, we can make a number guessing game. We'll start with that then. So we'll ask, we'll get the magic number here is going to equal random.randint. Let's do 1 to 100. Okay, and then we'll ask the user. So we'll have a guess is going to be an int of an input, and we'll say guess a number 1 to 100. Right, and then we can say, hey, if the magic number is, or we'll do guess first, right? If your guess is equal to the magic number, we'll print, you guessed it. If it's not equal to, then we can look if the guess is less than the magic number. Sorry, else if the guess is less than the magic number, we'll print too low. Else, right, if it's not equal to and it's not less than, it's got to be greater than. We'll print too high. Right, and then I guess we could ask them to guess again if we wanted. Right, maybe we'll say guess is equal to guess again, I don't know, or guess again. Sure, why not? And then we can check. So if I want to do this again, I just have to copy paste some code a couple times here. I'm going to feel bad about myself, right? That general rule of thumb, if you have the same code more than once, you should feel bad about yourself. But, you know, this is the only way we've been able to do it so far. So let's try it. So I don't know what that magic number is, but if you're going to guess a number, right, and it's random, here we want to split the difference. We want to start in the middle. So we guess 50. 50 is too high, so we know it's between 0 and 50, so 25, right? Split the difference. Still too high. All right, between 0 or 1 and 25, so let's do 13. That's too low, so between 13 and 25, split the difference again. We're somewhere about 19. 19 is too high, so between 13 and 19, we'll split the difference. And let's, is that 16? Yep, that's what we're getting to here at Maglet in just a second. So 16 is too high, so it's between 13 and 16. How about 14? 14 was too low, it's got to be 15. And we guessed it. Look at that, we can guess a number. Right? But now I have the same code in here more than once, and if I want to change anything, like I have to change it a bunch of places because I copy-pasted it here. And that's no good. So the first thing we're going to look at here is how we can make code run again. So what we want to look at is what condition will make this run. So we have this loop. It's called a loop or an iteration called while. So while says, as long as this thing you put here is true, run the loop. Start at the top, go to the bottom, and then when you're done running the loop, come back up to the top. And then check. If it's true, run it again. If it's true, run it again. If it's true, run it again. So I want the loop to run as long as guess does not equal the magic number here. Right? As long as you have not guessed the number, I want to run. So it gets a colon, and we can tab this all in. Now, this if will never be true here. Right? Because this loop will only run if this is true here. It's almost like an if, right? You have this expression that this will either be true or false here. So if this is true, this one can't be true, right? You can't be not equal to the number and equal to the number. So this is when the loop is over that will say we guessed it here. So I can just check, hey, if you're less than, you're too low. Otherwise, you're too high. And then at that point here, I can just have my guess again down here, which is nice. Right? I can do it one time, regardless of if it was too high or too low. I'll ask you to guess again. Then when we're done, we can print, you guessed it. So this while loop is going to, when it gets to line 7 here, it's going to say, is this true? If it's true, this entire block of code will run. Remember, so we get this colon, everything that's indented underneath belongs to the while loop. If the while condition is true, the whole block of code runs. When you get down to the bottom, and you get here, Python gets here, goes back and checks the condition. Okay, if it's true, the whole block of code runs. We get here, go back up to the top, check the condition. If it's true, the whole block of code runs. So now, with just a single while loop, as long as the guess is not the magic number, we're going to be in the loop. So I can guess 50 is too high. All right, 25. 25 is too low. All right, how about 37? 37 is too high. How about 31? 31 is too low. Between 37 and 36, or 31 and 37, would be 34. 34 is too low. 35, and we guessed it. We guessed the number, right? Because as long as the guess was not the magic number, this kept running. As soon as we guessed the magic number, we guessed 35, it got to the bottom, said, okay, go back up to the top. Is this true? Is the guess not the magic number? Well, that's false because it was the magic number. So when this is false, the loop ends. So it ends or doesn't run. So while loops here then are used to run something while this condition is true. As long as this is true, it'll keep on running over and over and over. So Python's really nice. It's pretty English oriented, right? While this is true, the loop runs. Now, if we wanted to, we could also start tracking how many guesses the user took here, right? So we could have a number of guesses. I'm going to assume is 1 here, right? Because this is your very first guess. And then we'll ask them to enter a guess, and I'll take my number of guesses plus 1. We'll increase it every time we guess. So then we can say, you guessed it in number of guesses, right? So we can start counting the number of guesses that it took here inside of our loop. So before we had the copy paste, this would have been a big pain to go and add this a bunch of different times, right? To like 7 different places when I copy pasted. But now we can run it here. We'll try it again. So now it's going to count our number of guesses. So 50 is too high, 25 is too low, 37 is too low, 42 or 43 or so is too high, about 40 is too low, 42, 41. 41, we guessed it in 7 guesses. It's not too shabby. That makes sense so far? So the next thing we could do then, if we wanted, we could ask the user. So we'll say, okay, how about we ask the user how high? So we'll have the top value. It's going to be an int of an input. How high of a number do you want to guess to? And that top value then we can stick in instead of 100. So then I guess instead of guess a number 1 to 100, It's guess a number 1 to the string of the top value. This is a little bit unfortunate. We got to go change it here, but that's okay. We can fix that to the string of the top value. So now if I want to play again, all right, well, let's just guess 1 to 10 here. All right, 5, 3, 2. Look at that. We guessed it in 3 guesses. Guessing a number 1 to 10. Sure. How about 1 to a million? Okay, 1 to a million. So let's guess 500,000. Right, split the difference. Too low. All right, 750,000. Too low still. All right, 875,000. Still too low. 925,000. Still too low. Okay, 960,000. Still too low. Wow, we're getting large. 980,000. Still too low. Okay, 999,000. Still too low. That is a large number we got here. So 999.5. Still too low. Oh dear. 9975. Okay, now we finally got it too high. So somewhere between this 2,500 values. Finally, I was expecting some values here. So if that's too high, then 996500. That's too high. Okay, so 99600. That's too high. Okay, so we're within. Oh, it's still too high. So we're within 1,000 now, right? And it's less than or more than 995,000, less than 996,000. That's not too bad. So then 995,500 is too high. Right, we cut off another 500. So 995,250. Okay, cut off another 250. So we're within 250 now. 995,370. Sure. Too low. 995,430. It's too high. Right, now we're within 70 values here. 995,400. It's too low. We're within 30 values here. 995,415. It's too high. We're within 15 now. So 995,407. It's too high. 995,404 is too high. 995,402 is too low. All right, we found it. 995,403. 21 guesses to guess the number between 1 and a million. Not too shabby. Right? Splitting the difference every time. That was super exciting. But this loop will keep on going as long as we want it to. So let's run it again. Let's guess a number 1 to 1. 2. It doesn't care what we type in, right? The loop's going to keep on going. Over and over and over, right? As long as we don't guess the magic number, this loop will keep going. And we'll keep counting our guesses here. Right? Much as we want here. So the program doesn't have to end. Right? If the user never gives you the right value, like your kid just sits here, keep punching in 4, 4, 4, 4, 4, and they say, Dad, it's not working. So you have to guess a different number. 4, 4, 4. Usually they catch on a little quicker than that. But eventually you can punch in the right number and it will end. So a while loop, when we talk about iterations, how many times is this going to run? It's indefinite. We don't know how many times it's going to run. It's not up to us to figure out how often the while loop is going to run. It'll run as long as this is not true. So you've got to be a little careful here, right? If you, let's see, let's put something here at the top. So if we say, let's ask them to enter a value. So we'll say a value is an int of an input. Enter a value to count down from. Count down from. Okay, and I'll say while the value is greater than 0, to count, thank you, count down from. I don't type as fast as I talk, or maybe I type faster than I talk, I forget. It's or the two aren't connected, my fingers and my mouth. So we'll print the value, and we'll take the value -1. Right, so if you give me 10, I'll print 10, and then 10 turns into 9. 9 is greater than 0, we'll run again, run again, run again, run again, run again. And then when we're done, we can print blast off. Right? So give it a shot. So enter a value to count down from. Let's do 10. Right? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. Pretty cool. What happens, though, if I give it something that... It's larger? I guess it won't be infinite, right? If I give it 1,000,000. It's just going to take a while. So printing something to the screen is actually really slow in terms of the computer operating. Right? In how fast computers can do things, this is one of the slowest. Printing something to the screen because you have to display the value. Yeah.
So the value minus equals sign 1.
Mm-hmm.
So if you enter a number, it subtracts 1 every time.
Yep. So it prints it and then it subtracts 1. It prints it, subtracts 1.
Stop.
So it will stop and it will only run as long as value is greater than 0.
Oh, okay.
So as long as so as soon as we get from 1 to 0, we say 0 is not greater than 0, and the loop stops.
Okay.
So the other fun thing is if I give it a negative number, something that's, or if I give it 0, we just get blast off. Right? The while loop will never run because 0 is not greater than 0, or negative 10 is not greater than 0. So while loops are not guaranteed to run. They can run indefinitely, or maybe never at all. Right? It depends on what's starting the loop here. So if you're asking the user to enter something, it's possible it never runs because they gave me a value that made the loop never run. And that's okay, right? You want the loop to run while this is true. If it's not true, the loop doesn't run. So it's also known as a pre-test loop, right? We're going to test this condition first, and then we're going to run the loop if it's true. So it might never run. Right? Other really fun things we can do with loops here. So if we, yeah.
So if you said while value is less than 0, then enter a negative number, what would happen?
So if it's less than 0, keep subtracting.
Yep, and then you start with a negative number.
Negative 1.
That would just go on forever.
Well, it will never not be true, right? So eventually, I think it'll crash. We can only get to so large of a negative number before we run out of room for storing it. But with Python, that's many, 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 many quadrillions, I want to say. I don't know, what is the largest? It's going to be a while till we get there, right? So, and this will just run. Right, and there's nothing I can do here, right? It's just running. I can stop it, right, with my debugger here. I can stop if I want, but aside from that, it'll just keep going. So what are we at so far? That is, how many digits there? 3, 6, can't even see here. 3, 6. Okay, so we're only at 4 million so far. Right? All right, there's 5 million. Right, so if we got to go up to like 2 billion or so for a regular integer, but you can store numbers larger than regular integers with Python. You can store some really large whole numbers or really small whole numbers. I guess negatives are smaller than big numbers. So it could be infinite. Yeah, you got to be careful. So if you put the wrong sign in here, bad stuff will happen.
So it's not based on the initial integer value. Well, what I mean is, once you define the variable as an integer, fail.
So
64,000.
It'll go up to 2 billion as an integer, but Python will happily convert to the larger long type. What is it? Python max integer. Let's Google that. No maximum limit.
Oh, it's not.
Woo!
It's not a 16-bit.
So generally, it will store integers in 4 bytes if possible. It can store larger ones though, right? So like there's certain types to it. So if I think it is even still an integer, but you can figure out the size of it here.
I was thinking it should just crash.
So other languages that are strongly typed will crash when integer runs out, right? Or do bad things, or you get some really unexpected stuff. So like subtracting 1 from a negative max value in Java will give you some really weird stuff. Python will just keep on going and get big. Yep. Our random imports from later on in the program, Orlo. All right, so you do need to be careful, right? One of the ideas here with your while loop is that something should change what's being tested here. Otherwise, you have an infinite loop, right? If nothing ever changes this value that you're comparing, your loop's infinite. Right, so we're subtracting 1 from value. So we're approaching this condition here. In our game here, we said, okay, I'm going to keep on guessing. So I'm going to keep changing guess. Now, they might not enter the right number. They might take a million guesses to guess a number 1 to a million because they're going to do a 1, 2, 3, 4, 5, 6, right, all the way up. But eventually, they have a chance to get this right here to make the loop stop. Okay, Now you might see, and I think this is really ugly here, some people say while true. I'm really not a fan of these here. This means run forever. The reason why you can do this, and it's not technically illegal here, we'll just say, hey, how about enter a value here? Oh no, let's use value here. We'll go back to value. So we'll say while true, print value, and then we'll say value plus equals 1. And then I'm going to say, hey, if value is equal to 10, use this word break. Now break means ends the loop. So if you know what should stop the loop, you should just put it here, right? I think this is really lazy, right? You know it here, use it above, right? I guess that's right here, right? So this here. So the textbook shows us a couple examples of some of these crazy loops while true. Now this one is actually infinite, will never end here, but it's saying, okay, keep entering something, and then if they give me the word done, break. Well, that's silly, because if you know what it is, just put while the line does not equal done up here instead of a while true. So I'm not a fan of this style, although you'll see people do it, because I don't control people or set rules. I just get to complain about things. Yeah?
How would you write something that you want the program to monitor, but interrupt and not clog the CPU?
That's a whole different thing.
Okay.
Yeah. You need multi-threading for stuff like that. So, and I don't think we ever get into that at this point. Yeah. We'll never get into multi-threading, unfortunately. That's much more an advanced topic. Or you just run it every minute. So like your operating system has ways to schedule a task to say run every minute or every 10 minutes or every hour. You can say, hey, run this Python script. So if you want something to like watch a folder for files and then do something when files show up, you can just run the task every so often. Okay. So again, the while true is ugly, but the break keyword will stop the loop, will end it real hard. So the other way to do it here then, right, the better way, we would say while value does not equal 10, right? We'll print the value. Oops, not cut, here, copy. And add 1. Now, this is risky here because it might already be above 10, and I'm only adding 1 to it here. I know it's going to get down to 0 because this loop will finish when it's 0 or less. So eventually adding 1 will make it hit 10 here. So maybe we'll say, how about 20 here? Right? So we can blast off and then we can come back up again. So we start from 10, we get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off, and then starting counting up. Right? True, the loop will run, we'll print the value. Value is 0, we'll add 1 to it. If it's 10, break. It's not 10. So we keep on going, we get to 10. This loop ends. The next loop will start. All right, value is not 20, so print the value, keep adding 1 to it. Once we hit 19 plus 1, sorry, it's down at the bottom here. I wish I could move I think I can move it up here. Can I move it up? Oh, I lost it. Oh, goodness. Where'd it go? There it is. Okay. I thought I could move that whole tab, but maybe not. Where can I put it? Can I put it somewhere? Nope. There? Okay, that's up at the top, I guess. That's funky, but sure. It's my project view. Is that better? So you can like kind of see it, at least the inputs? I lost my project view though. That's sad. Where'd it go? Files? Project. I don't know. I'll come back to it. That's fine. Well, we can see right, it'll count the values down, and yeah, we just stopped here. It's ugly now, though. Sure. So while loops. Right, so you can break to end the loop, so it's like a hard break. The other thing I'd like to do with loops is validating input here. So we can say, hey, let's enter a number. So we'll ask for value, and we'll say another value. We'll make an int of an input. We'll say enter a value 1 to 10. Oops, another parenthesis. There we go. And we'll say while another value is less than 1 or another value is greater than 10. Right? If either of these things are true, I want this loop to run. So if I asked you to enter a value 1 to 10, and you gave me something that's less than 1 or greater than 10, I'm going to tell you you're dumb. Print, that's not 1 to 10. Try again. And I'll just copy paste because I'm lazy. Right? So this here I like to call a validation loop. Validation, T-I-O-N. So it's going to validate the input here. That you can't make this loop stop until you give me something that makes this false. So it's a little bit backward. So what the condition is here is checking for invalid. Right? So the while condition checks for invalid values. So if less than 1 or greater than 10 are invalid, this loop will keep on going and keep asking you to enter a number 1 to 10. So we're going to validate the input here. And I can't get out of the loop until you give me something that is 1 to 10, right? That makes both of these false. So the value 1 is not less than 1, and it's not greater than 10. False or false. The whole thing's false. As soon as we get a false, the while loop will stop. It might never run at all. If you give me 5, the while loop never runs, which is okay. There's not a problem. We want that to happen. Right? So I know I have a number 1 to 10 here. Then we can do some silly things here. So we'll take that value 1 to 10, and then we'll tell them, we'll print your value times 9 is, and then how about we take value times 9 here, and then we can print, I guess we should, I don't know, that's fine. The tens place is, now to get the tens place, right, that's value times 9, and then we want to floor division by 10. How many tens we have, right? If the value is 1, we have no tens. If it was 2, we have 1 10, right, and 18, on and on and on. And then we'll do the ones place here. So that's modulus 10 is the remainder when we divide by 10. And we'll print the sum of the ones and tens place is, and I can just put in here 9 because I know it always is. But you know, you could do that arithmetic yourself if you wanted, and add these two things together. Plus this. This is that nines thing that's really funny, right? Any number you multiply by 9, the sum of the digits will be 9. Or the sum of those digits, if you sum those up, will be 9. Nines are fun. So it's a weird thing in math. Okay, so number to count down from, sure, 10, on and on. So enter a value 1 to 10. 20, that's not 1 to 10, try again. 0, that's not 1 to 10, try again. Well, what number should we give it? Oh, I was going to have it up here, that's right. Did I forget? Go to the left. I can't even put it there now. All right, I broke it. I broke PyCharm. I can't make it go to the top, I'm sorry. It was working for a minute. What number should we try? What value? 5? So value 5 times 9. Uh-oh. Oh, this is supposed to be another value. Oops. Another value. That didn't look right. Another value, another value, another value. So I don't know. Did I tell you these shortcuts? If you just double click on something, it'll highlight the entire word. That's how I'm grabbing those real quick. So it's double click to highlight, double click, paste, on and on and on. I'm not doing magic, I promise. I love shortcuts though, so I'm going to use shortcuts all the time. Let's try it one more time. 5. So 5 times 9 is 45. The tens place is 4. The ones place, that's a bad copy paste. Ones place is a 5. The sum of the ones and tens place is 9. Go figure. Right? Now this will actually work with larger numbers, right? So it doesn't necessarily have to be between 1 and 10. You want to do up to 3-digit numbers? We can do that. So let's do 1 to 100. So we'll get values 1 to 100. Okay? So we need to then add in the hundreds place here. Could do that. It's getting a little tricky, but let's get a number 1 to 100. So at most our number will be 900, right? 100 times 9 will be 900. Smallest it'll be is 9. So we're going to be between 9 and 900 here. So do we want to find the hundreds place? We only need one of these here. The hundreds place is. So floor divided by 100, right? Will tell us the hundreds place. Wow, that's so cool. JetBrains, the maker of PyCharm here, just came on and gifted subs. That's crazy. Thank you so much, JetBrains. Your software is awesome and we love it. And thank you for donating to the Student Scholarship Fund over at the University of Michigan Dearborn College of Engineering and Computer Science. Wow. That was really cool. So that was 10 gift subs. So Twitch keeps half. They give me half. So it's $25 towards the scholarship fund there from JetBrains because we're using their software. That was really neat. All right, so we need the hundreds place, we need the tens place, and we need the ones place. So floor divided by 10 is not going to give me the tens place anymore, though, if we have a hundreds place, right? So this math isn't going to work now. We need to fix it up a little bit. So we want to first take the remainder of dividing by 100. So we want to take that number modulus 100, then floor divided by 10. Because this will get rid of all the hundreds here, right? And then give me the tens place. Gets a little messy here, but let's try it. Oh, we didn't, so we should probably start saving some of these things here. So let's do the, I don't know, another value times 9. Here we go. So another value times 9. Then let's do our another value times 9 here. So it'll save us a little bit in here. Make that a little bit cleaner. Not perfect, but we're getting there. And then we don't need to do, so if we're going to be adding them together here, right, well, okay, we probably want to save it here so we don't have to repeat the arithmetic here. So then hundreds place can equal this one. It'll be our hundreds place. And then we'll have our tens place. Tens place is this one. It'll be our tens place. And then our ones place. It'll be this one here. It'll be our ones place. Then I can add them together here. So ones, tens, and hundreds. So hundreds place, tens place, oh, hundreds plus tens plus ones. We'll add all those ones together. All right, so let's try it. So 10, what number do you want? Between 1 and 100. We'll multiply by 9. 7. So 7 times 9, 63. There's 0 in the hundreds, 6 in the tens, 3 in the ones. Sum is 9. That worked out. Let's try something a little larger. 46. So 46 times 9, 414. 4 in the hundreds, 1 in the tens, 4 in the ones. Sums up to 9. Let's try it again. 72. All right. 6, 4, and 8. So that adds up to 18. Oh, well, now we have to repeat. So our sum is greater than this. We need to do it again, right? Okay, well, we can do all that. So we can take all of this, and then we can say, how about, let's see. So if we want it to run again, as long as that sum, so how do we get the sum? So sum of digits, there we go, is equal to this thing here. So we have the sum of the digits. And we want to keep on doing this then while, let's start here then, while my sum of digits is greater than or equal to 10. Oops. So the problem is I can't do something with a value that I'm creating inside the loop, right? Because there's nothing to check here. If the sum of the digits is declared inside the loop, it doesn't have a value at the start of the loop here. It's not going to work. Right? So I think we need, let's see, so we didn't change any of that. So we need to change then, so if the sum of the digits then, so we need to change the another value times 9 then. Needs to equal the sum of the digits. Sum of digits. There we go. And we can repeat that arithmetic with that another value times 9. So what you want to do then, if you want this to run, oh, that's so cool. Hey, let me, hang on, you got blocked out here, JetBrains. How do I permit you here? Sorry, 1 second. They're trying to give a link for free software. Okay. Sorry about that. I think that'll work with the link here, JetBrains. So if you want the loop to run, we need to give it something that makes sure the loop runs. So I can take sum of digits, and I can assign it a value that will run. So this is a dummy value, ensuring it runs at least once. So, because if it's not true, the loop won't run at all. So I need to give it something that makes sure the loop runs, and then we can just keep on going over and over and over and over again. So let's try that. So let's give that a run. I think we had 72 was the value here, right? I messed it up. So 10 for our countdowns. All right, 72. So 72 times 9, 648. 100th place is 6, 4, and 8. Sum of the 10 is 18. All right, so I guess we want to skip this. Your value is. That's a little bit unfortunate. But then we get 1 and 8, right? And they'll sum up to 9. So it sort of works here. Sort of. Let's see, maybe we should print that here then. Your value times 9. Maybe we do that outside the loop here. How about that? Okay, or should we have, I don't know, the current value? We could do something here to make it work, but this ought to do it here. The sum of all the digits. We could go even larger if we wanted, into the thousands place. Well, we need a thousands place addition in here, and that gets a little bit crazy, right? But we could. To automate it gets a little bit trickier, but we could do that too. Okay, we could start getting all of our digits out one at a time, because it sort of works the same way. Oh, thanks so much, Professor Burp. So there's a link in chat, jetbrains.com/pycharm/buy with student discount. Students and teachers can get PyCharm for free. So that's their full-on version instead of the community version. Yeah.
I'm still not entirely sure how you have it so it knows what's in the hundreds, tens, and ones.
So whatever that value is times 9 here, if we floor divide by 100, it's how many times can we count 100 into it as the integer value. It's this double division sign here, so we don't want any decimal remainders. So if your value is like, what is our first value? 700 or 648, right? It's going to say, okay, divide by 100 and then get rid of the decimal place. So 648 divided by 100, 6.48 gets rid of the decimal. It's just 6.
So what's the double division called?
Integer division or floored division.
Floored?
I prefer the word floored division. So because it will take your result and turn it into an integer, which will get rid of any decimal remainder.
Okay.
Yep. I think a couple of people also, you could say int of this result here if you wanted. It does the same thing. It gives you an integer result back out, which is the whole number rounded down. Yep. So if we wanted to go the other route, right, we could start finding all of the digits, adding them up here. It gets a little trickier, but we could. Probably not worth the math at this point, but you can just floor divide by 10. I'm sorry, modulus 10, and then take that result, divide by 10. We'll get rid of that ones place. And then you have a shorter number, and a shorter number, and a shorter number. It's probably not all that interesting to look at, but we could then get a result. It's harder to name things that way, though. So all you can really do is do sums here. But this ought to work. All right. Questions, thoughts, concerns? So it's a little much to start, but validation loops, right? As long as this is true, keep on running. Where being true means it was invalid, right? If it's invalid, run it again. If it's invalid, run it again. So I can make sure that I never get to the next line of code with an invalid value. Which is super handy, right? So we could add in these sorts of things if we wanted inside of our game if we wanted, like guess a number, too high, too low, right? To make sure they don't guess an invalid number here and waste their turns if we wanted. Again, not all that interesting, but you could. So why don't we take a break? I think when we come back, we can, let's see, what do we want to do? Yeah, we'll look at some other examples. We can make the computer guess the game too if we wanted and solve itself. That's probably not quite as interesting though. But want to take a little break? We'll take 10. Get some more Diet Coke or coffee. My coffee pot is broken. I'm super sad. It's under warranty, but the local service center for Black & Decker only fixes tools, not coffee pots. Go figure. So I have to like ship it somewhere to Black & Decker for them to ship me a replacement coffee pot. But I'm doing my French press little miniature pot. I'm on pot number 2 of that today, and it's going really well, and I'm super hyped right now. So, all right, folks, we'll take 10. We'll come back in a little bit. Let's put this music back on here. Yeah, and thank you so much for dropping by, JetBrains. That was super cool of you. We also use IntelliJ for the Java class, so we love your software here. Howdy, folks. Welcome on back. All right. So I switched over to Diet Coke. I finished off the coffee here, but I'll be nice and hyper. So feel free to jump in anytime, and I'll try and be quiet here. Okay. So more with loops here. We'll leave some of this mathy stuff behind. Don't worry too much about it, but I think it's fun, and I'm a big nerd. It's okay. Just the idea is that our loop will run as long as this is true. That's sort of our goal here. So some other fun things we can do. Let's take that validation loop we were doing, and let's turn it into a function, because that's would actually be really useful here. So let's define a function. This is a, I don't know what, get number between values. So if you give it a min value and a max value, we can write a loop. So if you tell this function what the minimum value is and what the max value is, we can keep on going, right? So we'll ask for an input here. This is probably a integer, right? Get int, probably better than number, right? Because specifically integers, not floating points. So we'll ask. We'll get a value here then. Will be an int of an input. We'll say, please enter a number between, and then we want to add in here the string of the min value. Min value. This is getting a little long. Let's bump that down. So string of the min value plus a dash sign plus a string of the max value. Max value. There we go. Okay, so we'll get that value. We'll ask him for it. We'll tell him what the high is, what the low is. We'll ask for it here. And then we'll start the loop, right? This will be our validation loop. So we'll say while the value is less than the min value, or the value is greater than the max value. If you give me something less than the min or greater than the max, it's invalid. I want this loop to run. I want you to be stuck. And I'm just going to not even bother with another message. I'll just ask him to do it again here, right? We'll just say, okay, give it to me again. I'm going to feel a little bad here because I have the same line of code twice. To work around that, we could make sure we started like min minus 1, right, if we wanted to, right? So like min minus 1 to make sure this loop runs at least once. That's probably okay. Again, we didn't really save a whole lot here though, but the idea is that I'm making sure the loop runs at least once. So start at invalid, so the loop runs, right? If you subtract 1 from minimum, you're going to be less than the minimum. This will be true, the loop will run. That way I don't have the same prompt in here twice is all. That's not too big of a deal. When I'm done, I can return the value. What does it not like about value? Oh, I'm using the word value other places. But now I have a cool function that will do validation for me. Now, before I told you functions probably don't deal with input, this is one of those good exceptions. Like, the job of this function is to get user input. Right? It's not like that quadratic equation solver where we might want to use it other places. So if it's supposed to be getting input, yeah, we'll ask for input. Otherwise, functions generally just use their parameters. Again. But now we can get our value here. So I can use this prompt here then in our guess again, right? So guess a number. I guess we lose the word guess here. So, you know, enter number between instead of guess a number. Is that the worst thing in the world? What we could do instead then here, let's do this. Let's say, okay, remember you can have optional parameters. So we'll have a prompt. And I'll say, if you don't give me a value, I'll assume this is the prompt. If you want to give me a different prompt, then I can use that prompt. Right? In other words, you can have something, so if you don't give it a value, you'll get this default. If you do get a value, you'll get whatever you asked for. So now we're going to ask for a value here. Let's see. So this is going to be enter value 1 to 100. We'll say this will be a validate get in between 1 and 100. And I don't need to give it a prompt here, right? It will just say, please enter a number between the min and the max, right? Between 1 and 100. Sure. right? And then same thing here, that's not 1 to 100, and then we'll just do it again. So this function is going to return a value. Now for our guessing game though, right, we want to change that. So guess a number, 1 to something. So that will be our prompt here, 1 to the top value. So I'm going to use the guess and int between values 1 and the top value, and I'll say guess a number. Do we need the word between? I think we need the word between. Yeah, guess a number between. And then this one we can change again. Same thing. We'll paste in. Oops, that was the wrong one. We'll change here to be a guess again. And then we probably don't even need to say guess a number. We'll just say guess again. And it will say the one do whatever the top value is here. So now we have the function, right? It will do the validation for us. It won't let us guess an invalid number, which is pretty handy. So enter a number to count down from. Sure, a number with that. Digits, sure. How high of a number do we want to guess to? Let's do 100. So guess a number between 1 and 100. 200. Guess a number between 1 and 100. 300. Guess a number between 1 and 100. 50. 50 is too high. Guess again. Right? The prompt here was guess again. Sorry, it's all the way down at the bottom of the screen here. I don't know if you can see it any better on that screen, but all right. So 25, too high. 12, too low. 17, too low. 22, too low. 23, too low. 24. 7 guesses to get a number 1 to 100, and it's doing the validation for us. Right. So using the function and the validation loop here, make sure we get good numbers. Pretty happy. Does that make sense? How we can use the validation loop? Okay. Other cool things we can do. Now, this gets a little uglier here, but it's okay. Let's see. Let's go back to, we'll make it up here. So define, let's go back to our rock, paper, scissors, lizard, Spock game here, because everyone loves that. So rock, paper, scissors, lizard, Spock. I don't know what, how about prompt 4? For rock, paper, scissors, lizard, or Spock. I don't need any arguments here. I'm just going to prompt them for it. So we'll ask for a throw, right? So we'll get their choice, I guess, can be an input of, I don't know, rock, paper, scissors, lizard, or Spock. Or what, I don't know, what do you throw? What do you throw? Rock, paper, scissors, lizard, or Spock. Okay? And I can say while my choice. Now, with this, we probably want to lowercase it because I have no idea what they're actually going to type in, and dealing with casing is annoying. So at the end of this, I can say to lower or dot lower. Right? We'll take their input and lowercase it. That'll save a little bit of trouble here. And you say, well, choice does not equal rock. And so this one here, we're going to be a little funny. We need to and all of these together because we only want it to run if all of them are not true. Because if it does equal rock, this will be false. So I can't use ors here because your choice will never be all of them. Right? There's no valid range to say, okay, if it's less than this or greater than this, it's if it doesn't match rock and it doesn't match paper and it doesn't match scissors and it does, so we just have all of them in here. Paper and choice does not equal scissors. And oops. I think we need to add that slash. There we go. And choice does not equal lizard. And choice does not equal Spock. Okay. If all of that is true, right, means it's not rock, and it's not paper, and it's not scissors, and it's not lizard, and it's not Spock, we'll ask them to guess again. So, and again, I feel a little bad here having to do this input twice. And I just copy pasted, but if we ever want to change it, I have to change it 2 places here. So I'm going to set choice as just an empty string. An empty string is not rock, it's not paper, it's not scissors, it's not lizard, it's not Spock. This loop will run. I think we want to tab those in one more. Is that happier? Okay. If we tab it in one more, it's a better visual lineup here. They can get their choice. If it's not rock and not paper and not scissors and not lizard and not Spock, it'll ask them again. It'll ask them again and again and again and again. When we're done, we can return choice. There's better ways to do this, but we haven't talked about lists yet, so I'm not going to worry about it. Okay? Lists are better for this. We aren't there yet. Okay? So don't sweat it here. Right? So I can use this prompt here then, or this function, to get a value. Oops, there we go. Comment. Oh, I lost my import. That was weird. I think I hit enter in the wrong place. Or random. Import random? There we go. Are we using random? Yeah. Yeah, random. There we go. So another validation loop, but this one with strings, right? So again, well, the idea here is that this is the invalid case, right? If it's invalid, run the loop. Same with our numeric validation. If it's invalid, run the loop. We're doing the same with our strings. Yeah, you could definitely use enum's Dota 2. We haven't got to that yet. So we had done, I think, was in my solution, I did number values, 1, 2, 3, 4, and 5, and said enter a 1 for rock. You could do the same idea here with a validation loop, like with your values, 1 through 5, numbers 1 through 5. Right, so if you went for strings, you can compare strings. Just trying to show lots of different ways we could go about this here. Okay. All right, and so one of the things we're looking at for the next project, and it's not required, but this is like, it would be a good practice here, when you're asking the user for one of these choices here. Right, at the end of this, we say, choose an action 4 times from the menu. Right, that menu function could do some validation. Right, did you enter this or this or this or this? If you didn't pick one of your 4 actions, ask them again. Not required at all, right? Because we hadn't got there yet, but that's the sort of thing would also be helpful as well in this sort of menu function, right? Function for menu prompts the user to enter an action. We're just returning their choice. They could have given us garbage, right? It doesn't have to match one of these possible valid values because we didn't validate it. But now we have the tools, we could validate if we wanted to. Hey, you didn't give me a good option here, right? Try again if you want to be helpful. Okay, so just, again, not required, but keep that in your back pocket. That's a helpful thing you can do with these loops. Okay, let me, the other thing you can do, so we looked at the break keyword, which will end the loop. There's another keyword called continue. Continue skips to the next iteration. It jumps back up to the top. It says, okay, start again. I don't like continues. I don't like breaks either. I feel like they make things harder to read. Because again, my focus is the code is for people. Right? There's ways you can do this without using the continue keyword, and ways you can do it without using the break keyword, but it's a tool. It's a way you can use it. So they're saying, hey, you enter some values here. If it starts with the £, not a hashtag, this is a £, or octothorpe, if you want to be fancy. You can use the real technical term for it here. Continue, don't do anything with it. Go back and get their next input. Sure. Right, just like it's a Python comment, right? If you put something with a comment sign here, it doesn't do anything. Right? They're kind of imitating that. Now, this line square base is 0, we haven't talked about yet. So this probably means garbage to you. Next chapter, we'll talk about strings and what some of this square base notation does for you. But again, Dr. Chuck kind of jumps around just a little bit to give you a flavor of what's coming. I guess if he was an author, you'd call that foreshadowing. But again, that's okay. Yeah, I think most people don't break or continue Dota. It's generally just a little ugly. It's okay. I mean, they can be useful. But all right, so that's the while loop. Couple different ways of using while loops. Could be infinite. You got to be careful. The next kind of loop we're going to look at is a for loop. And now for loops are some of my favorite loops out there. So while a while loop was an indefinite loop, actually, let me go, sorry, I'll leave the functions at the top and I'll come down to here. So the next kind of loop then are definite loops or for loops. They will do a certain number of times here. So I'm going to say I want to for, I'm going to say value, and then you use some funny syntax here. We say in, And I'm going to show you, this is not in the textbook. I don't know why he doesn't go into range here. He doesn't go into range, but range is like the most helpful thing you can do. I'm going to say range 10. What range 10 gives me here, values 0 through 9. So when you range, it starts at 0 and goes up to but not including the value given, right? Up to but not including value given. So what this is going to do for me here then, I can say print the value. Same idea where you get a block of code, but what happens here is every time this loop runs, every time it iterates, value changes to the next value in this collection. So it starts off at 0, and then it's a 1, and then it's a 2, and then it's a 3, it's a 4, it's a 5, it's a 6, a 7, 8, and 9. So this one will run 10 times here doing something with value. Again, not the most interesting thing here, but we get 0 through 9. This is our for loop. So for loops are definite iterations because we know how many times they're going to run. It will run once for each item in a collection. So they run once for each item in a collection. So range 10, it gives you a collection of 0 to 9. So if you were to just say print range 10, like it'll print them all out for you, which is nice, kind of on one line. Nope. That's not what I wanted, sorry. Did not do what I expected. Forget that. Really thought I used to print that. That's not helpful. Sure. So once per value in here. So if I know how many times I want to do something, I can use a for loop. We'll go through a couple silly examples to practice here. So let's ask the user here. So we'll say, how about a size? We'll ask the user, and we'll say int of an input, enter the size square you want to print. So give me a value. And if it's going to be a square, I'm going to say for, this will be row in range size. So for every row in the square, right? So if you want a size 5, I have 5 rows here. I can print. Now remember, you can multiply strings. I'm going to take the star character here. I'm going to multiply it by size. So for every row, I'm going to print that number of stars. So if you said size 5, I'll print 5 stars. So we can make some ASCII art. So let's do 10. And I get a nice 10 by 10. I guess it's a little bit more rectangular the way the font comes out here, but I get 10 rows of 10 stars here. Because I know I need to run this many times. So doing a range of size will give me 10 times. Each one will give me this. So let's define square. How about we do length? Or no, how about rows? What size? What height? Rectangle. And then we'll do, oh, we'll call that height then, right? Because that's height. So height and width will be, enter the width rectangle you want to print. So now we can't range from size, but we can range from height here. So for every row in the height, we'll take a star times the width. And we'll print that out. So what height rectangle do we want? 6. Okay, and what width rectangle do we want? 12. So we get 6 rows with 12 stars each. So you can kind of see it's real small down at the bottom, but down here it tells me I've highlighted 12 characters. Real tiny, which is really super handy if you ever want to count things. So as you're highlighting, it tells you how many you have highlighted here. 12 characters, 12 chars there. Just a nice little thing there, so you can count it real quick. So now I have a cool rectangle. What if I wanted to do a triangle instead? Can we do a triangle? I bet we could, right? So our size here will be an int of an input size triangle. What do you want? Now I'm going to do a right angle triangle here. I'm going to do like 1 star and then 2 stars and then 3 stars, right? And then 4 stars, right? To make my triangle here. Just kind of make a nice left aligned one here. Yeah, Dota, it's the iterator under the hood for range. That we haven't got there yet. So I'll say for row in range size. Now, if the first row I want to print 1, and the next row I want to print 2, and the next row I want to print 3, well, what's happening with this row number here, right? We didn't actually use the value for row in this for loop here. Like our very first one, we said, okay, print the value out. You don't have to use this value here if you don't need it, right? For our rectangle, we just wanted to do something that number of times. I didn't care what the value of row was. It didn't matter if it was 0 or 1 or 2 or 3 or 4. But for our triangle here, the row is important, right? So at row 0, I need 1 star. At row 1, I need 2 stars, right? So I want to print the star character times row plus 1, because I don't want to do 0, right? Because its range always starts with 0. So ranges are a little bit funny that they start with 0. It'll make a lot more sense in 2 chapters why that's useful. Let's try it though. What size triangle do you want?
15.
15. All right. So row 1, 1 star, 2 stars, 3 stars, on and on and on. We should get 15 stars here. Yep, 15 characters. We printed a size 15 triangle using a for loop. Right? A definite iteration. We know exactly how many times we want to do something. It's the size, 15 times in this case. Or if you wanted 100, I would do 100 times. Right? Go nuts. It'll look really funny on your console, but you can. Okay? Let's try something else. So, have you ever wondered how random actually is here? Right? Because remember we mentioned it's pseudo-random. Do we talk about that? It's not really random. Please don't use this for anything that needs to be cryptographically secure. Because it's just Python code, and we can go look at what the code's doing. We know how it's generating random numbers here. But we could. So let's say I want to imagine, because our next project here has us rolling some dice, right? So sum of 6-sided dice. So let's look at some 6-sided dice here. So if we were to roll a number 1 to 6, right? That's the random randint 1 to 6 here. So let's try it 100 times. We'll say for roll in range 100. So for 100 times, let's go roll something. Now, if I want to count how many times I get a 1, how many times I get a 2, how many times I get a 3, how many times I get a 4, 5, and 6, I need a place to count those. Right? So I'll say 1s, and I'm going to start off at 0. This is 2s, 0. 3s is 0. 4s is 0. 5s is 0. And 6s is 0. Okay? We'll pick a number. So we'll roll a number. So we'll say, okay, so we'll have a, I don't know, number is random randint 1 to 6. And then if my number is equal to 1, we'll take my 1s plus 1. Now if the number is 2, take our 2s plus 1. Now if the number is 3, we'll take 3s plus 1.
Does Python have like an operator like plus plus?
No, actually, it does not have the plus plus operator like other languages do. So all you get is plus equals 1. I don't know why. Yeah, I would expect they would have added it by now, but apparently Python developers are insistent that they don't add it. I don't know why. So in other languages, if you programmed, usually you can say like plus plus for add 1. Python doesn't do that. If the number is 4, take our 4s plus equal 1. And if the number is 5, we'll take our 5s plus 1 plus equals, oh my goodness. I've reached the point where I think I drank so much caffeine I'm getting jittery. It's wonderful. It's a good feeling. 6s. You can start tasting colors. No? Maybe? Now, I left in this last elif instead of an elfs because if we wanted to, we could go expand on this and do more numbers. I don't recommend you do the D20 because having to do this 20 times is really annoying. And in 2 more chapters, I'll show you a way we don't need to do it like this. But we haven't got there yet, so don't worry about it. It's okay. All right, when we're done now, here, right? Let's go figure out what our results were. So we'll print, then I'll say 1s, and then I want to add in here the star character times the 1s count. Right? This will be the number of times I rolled a 1, print star times that. So we're going to make like a little histogram, right? Make a little chart out of it here. And then 2s times the 2s. 3s times the 3s. 3s. So we probably actually want to use that tab character. We don't usually use a tab here, but this ought to make this line up a little prettier here. The \T for tab, right, will like kind of automatically go to the next tab stop. So I think that'll be a little cleaner here if we do that. It'll be 4s, 5s, and 6s, right, and 4s, and 5s, and 6s. Okay, so we'll try 100 rolls of a die 1 to 6, and we'll see what we get. Okay, well, let's see. Let's zoom in a little bit here. So we got 18 1s, we got 7 2s, 21 3s, 17 4s, 19 5s, and 18 6s. Relatively random, right? It's not too bad for rolling this 100 times, right? If they were exactly even, it'd be really suspicious, because that's not very random if it's a perfect distribution with just 100 rolls, right? Now, if we wanted to, we could increase our number of rolls, right? We could test this out, say, let's do it 1,000 times here. The more you do it, the closer the numbers should get to each other, right? We shouldn't have the big gap like we did between 2s and 3s. Now, this is a little long here, but you notice they're all relatively close here, right? We can go even more if we wanted, but we could kind of graph this out. Now, that value, you know, printing it like like a histogram is pretty, not quite as useful. So maybe we would want to like show the percentages too, right? We could say, take the 1s divided by my count up here that we're doing this by to figure out what percentage of time we rolled a 1, right? Should we do that instead? Or do both? We can do both, right? So instead of the star times the 1s, let's take, and let's do this our, how about number of rolls? Number of rolls is 1,000 here. Because if I use a variable, then I can use the same number in case I ever want to change my mind, change it again later on. So we'll take the 1s divided by the number of rolls, right? 2s divided by the number of rolls, 3s divided by the number of rolls, 4s divided by the number of rolls, divided by the number of rolls, divided by the number of rolls. And we'll get rid of the stars here, right? We'll just kind of print it out with, there we go, with just the numeric results here. So if you don't want to look at the histogram, that's right, that needs to be a string here, sorry. Convert all that to a string. String of that, string of that. I wish it would suggest that. That would be nice if it could suggest it for me. Maybe it does. Does it do it? No, there's no suggestion. Alt enter? Nope. String, 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 string. Yeah, the central limit, yeah, that's the normal distribution where most things land in the center, Dota. All right, here we go. But we'll see they're pretty close in percentage here now, right? 15%, almost 16%, 17%. Pretty close to each other. Right? That's pretty cool. But again, if we did just 100 here, cut that down a little bit, we should get more of a variance here. Yeah, here we go, up to 21, as low as 13%, which you'd expect, because it's not perfectly evenly distributed. You don't get every 6 numbers as a 1, right? It's relatively random, or pseudo-random, like we'd expect. But again, we can do this loop, a definite loop, or iteration. I want to do it this many times. Now again, we didn't care about the number roll here. I didn't use the value of roll. Its first value was 0, and then a 1, and then a 2, and then a 3, on and on and on. You don't have to use it just because it's here. You can if you want to. So if we wanted to like print out what all the rolls were, we could. Right? So we could do that. We could say print roll number plus a string of roll plus a colon maybe plus the string of the value. String of the number. So if we wanted to print out all of our rolls here, we could. Right? I'll get all 100 rolls. So if you wanted to see what was happening, We could print them out if we cared. And totally up to you, right? You don't need to use the value that's here, only if you want to. Up to you. How you folks feeling so far? Now, the fun thing with this one here, so let's do, instead of 3s here, we'll just say continue. Right, this continue word means just jump back to the top. So this will essentially not count the 3s, right? If we never add to our 3s counter, we just continue, we'll never get any 3s. Right, that's the continue keyword. All of a sudden there's no 3s. That's real suspicious, right? We did a bad thing. But you could, right? So just trying to show that continue keyword there. Now break will stop the loop completely. So if we want to, like, if we said, hey, let's get to 6s here and break, this ends the loop here. So as soon as we get a 6, the loop stops. So we get a couple rolls, right? Look at that. It took us 18 rolls to get a 6. And then the loop stops with that break keyword. Right? As soon as we find a 6, the loop ends. Again, so very contrived example here, but we'll stop the loop or just go to the next iteration of the loop here with what we're doing. Yeah, the string interpolation, that's right. So we're covering strings next chapter, JetBrains, and we'll get into the string interpolation. Yeah, that is a lot prettier. We haven't got to those formatted strings yet. Thank you. That is the good suggestion. When I was complaining about turning these into strings, there's a better way. Next chapter we'll talk about that. Okay. So some for loops, right? Definite loops with for. Now, I'm sorry? Yeah, this is from the Dr. Chuck's book here. So this here is a list in Python. Again, don't worry too much about it here, but it's comma separated, and it gives you 3 different values. So his friends, Joe, Glenn, and Sally, here, you can loop through a collection, right? This for loop will do any sort of collection. So a list is a collection. So in this case, if you give it 3 friends in a collection, it will run 3 times. Happy New Year, Joe. Happy New Year, Glenn. Happy New Year, Sally. Yeah, you'll get the right order here, Dota. So it'll do it in order for these items. Again, we haven't got to lists yet. We'll get to that in chapter 7 or 8 when we get to lists. Sorry, so 3 more weeks. But then there's 4th of July. So I think after 4th of July, we'll get back to this. We'll get to lists. And we'll talk a lot more about making lists and dealing with lists and playing with lists. But if you have a list or a collection, essentially, that's a nice word for it here, you can loop through that collection. So range was giving us a collection of values from 0 up to, but not including the value we asked for. So range 10 gave me a collection 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, those 10 items. Same idea here. You can give it your own collection if you want, whether it's string values, right? Or you can do numeric values too, if you wanted. So this collection of values here, he's going to loop through and just count how many we have. Not the most interesting, right? If you wanted to, we could sum them together, right, with the total. Instead of counting them, you could sum them. You could find the min or the max, find the largest or the smallest, find the smallest value. So smallest, if it's less than the next smallest, great, go for it. He starts off as none. I think it's a little weird, but that's okay. I guess we didn't know what the value of 3 was before. So you can say, hey, I start at none. So if it is none or less than the smallest, sure, we have a new smallest. Generally, I'll say the first value is the smallest. But if you don't know the first value until now, then don't worry too much about it here. All right, so then I want to show you with our for loops as well. I'm sorry, one more thing with while loops. So we did validation loops. The other cool thing you can do with a while loop here is something I call a Sentinel value. That's generally the accepted term for it here. But if at the end of the day, you were working the cash register and you needed to total up all of your receipts, like how much cash should be in my drawer, right? You're going to enter a bunch of values. Now, you don't know how many receipts you have in that stack, right? You could have 10 receipts in the stack. You could have 100 receipts in the stack, depending on how busy of a night it was, right? So I'm going to do a loop that will run as long as you want to keep running here. So I'm going to start this is my receipt total, or running total. It's going to start off at 0. Okay? And then I'm going to say I want to do something while a value is true. Now, I need to start it off as false. So I'll have a receipt here then. I'll say is 0 to start. And I'm going to say while the receipt does not equal -1. Because you probably don't have a receipt in your drawer for negative. I guess you can return something here. Let's flip that. So let's say 0. And we'll start this off as like -1. It really, as long as it's not this value here, it doesn't matter too much here. And we'll say, okay, so my receipt then will be an int of an input. Enter the receipt value or 0 to stop. And I'll take my total here, my running total, add in the receipt. As long as the receipt's not 0, keep on going. Okay, enter the receipt value or 0 to stop. So this loop here then uses, this is a Sentinel value. Sentinel value is an unusual value used to indicate the end of the loop, right? So this idea is you don't need to know how many receipts are in your stack here. Just keep entering values. As long as you have receipts to go through, flip, 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 flip. Keep on going, keep on entering numbers here. As soon as you're out of receipts, you can give me an unusual value. You probably don't have receipts with a total of 0, right? If you have a receipt for $0, something funny's happening at your store, right? You might have negative, right? If you had to return something. I guess that does happen, right? If someone wants to return an item, they'll bring it back and you have to take money out of the register and give it to them instead of adding to the register, right? So this sort of loop here then lets the user run until they want to be done, which is super cool, right? So it's a little bit different than some of these other loops we looked at. It's not really a validation loop. We're not validating any input here, and we're not like just asking them to guess a value here, right? It lets them do a process until they're out of values, until they're out of something here. So then when we're done, we can print the total, print total receipts, can't spell receipts. Okay, and then a string of the receipt running total. Right, maybe even added the $sign to be fancy here. Oops, whoa, what did I click? I think I hit page down. So if I give it any value other than 0, right? Okay, here's a $10 receipt. Here's a $12.50 receipt. Oops, that's not an integer. Probably a float here, right? Because receipts, sorry. All right, 10, $12.50, 13, here's a -2, as whatever I want here, right? And then eventually a 0, and I'll get the sum. Oops, all the way back up the top here. So some sort of unusual value can be used to simplify this. Or I'm sorry, to like indicate the end of the loop. Without a while loop, we really had no way of doing this. We probably could have done a bunch of if-else ifs, right? If the value is not 0, ask them to enter a value, and like, I don't know how many times we would have done it, right? Are you going to enter, like, copy paste it 100 times because they might have 100 receipts, right? So we can see the while loop is really adding to the tools that we have to solve problems. The for loop does that as well. It's new things we can do that we weren't able to do before. Okay? Thoughts, questions? I know it's a brand new thing. So we've got functions, we've got loops, all sorts of new tools in our toolkit here. I want to look at a couple more examples of loops. I like these little ASCII art things where like we draw rectangles or draw histograms because I think they're fun. Where do we do our rectangle here? Yeah, our little rectangle or triangle here. So it's just a fun way to think about loops and the relationship between values. So for fun, what we did, this was a right-angled triangle that was left-aligned. Could we do a right-angled triangle that was right-aligned, where all the values were on the right-hand side first? So we have a bunch of spaces, and then star, and then spaces, and a star, and spaces, and a star. So like the output then, if we wanted like size 5, would be 4 spaces and a star, and then 3 spaces and 2 stars, 2 spaces and 3 stars, 1 space and 4 stars, and then 5 stars. Can we do something like that? Yeah, definitely. So what we need to do is find the relationship between the row number, the number of spaces, and the number of stars. So instead of, should we leave this one alone? We'll leave that one alone. We'll do it again here. So we'll say for row in range size. We'll do it again. So this will be our left aligned, right? This is our left aligned triangle, and we'll do this one as the right aligned. So how many spaces do I need on my first row? Well, remember, row's going to start at 0. So my number of spaces should be size minus row minus 1. Right, so size is 5, row is 0. 5 minus 0 is still 5, minus 1 more. Eventually, remember, you'll never get to the max here. So when size is 4, right, it'll stop. So before we were like adding 1 to row to get 5. So I think minus 1 is for number of spaces. So we'll print the space character times the number of spaces. Plus, then we want to print the star times the number of rows, plus 1. Right? So this number of spaces should be decreasing, number of rows should be increasing. I think we can comment all that out. There we go. That's Control/ for commenting it all out. Let's give it a run. All right, so sure, 1, 0, make it stop. What size triangle do we want? How big should we go? 8, all right. We get our first triangle here. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. That looks kind of cool, like back to back. Excuse me. All right, we worked that one out. It's not too bad. What about an equilateral triangle? Where all the sides are the same, right? Like a nice even triangle where that starts in the middle and then grows. Can we do that? Now, to do that one, I'll propose that we need an odd number here. So I'll say, here's 1, and then we'll do 3 stars, and we'll do 5 stars. Right? So if you go 1, 3, 5, relatively equilateral here. I know that it doesn't exactly work, but it's pretty close here, right? Because 2 isn't going to line up and won't look nice and straight. Or we could go 7, right? That's 6 7s, and all these need to be spaced in 1. Right? Size 7, equilateral triangle. We can do that. You want to try one of these? Of course you do. Of course you want to try one of these. Thank you for suggesting that. All right, so we say for row in range size. Now, this isn't actually going to work for us here because I don't have as many rows as size here. Right? Doesn't really work for us the way we'd expect here. So maybe we want to do something else then. Right? We don't have to use the for loop. You could, but you don't have to. So how about we say I need the number of stars. Number of stars starts off as 1. And while my number of stars is less than or equal to my size, let's do something. Right? Because that way I can start with 1 star and then add 2 stars and add 2 stars and add 2 stars. Right? Because we're adding 2 stars every row. Right? Okay. So we want to print the number of stars. Here, how about the star character times the number of stars? And then we'll take our number of stars plus equals 2. Well, that doesn't do the spaces yet, right? We still need our spaces, but that'll do my number of stars for me, right? It'll print 1 star and then 3 stars and 5 stars and 7 stars. The spaces here is a little trickier. So with a size 7, I have no spaces at this row. I have 1 space at this row. I have 2 spaces at this row, and I have 3 spaces at this row. So let's go back to math class here, and we're going to look at size. Oh, that's real small here, sorry. We can just do it in here. I think I've got larger font. So we're going to look at size, and we're going to look at spaces. Okay? Nope, just spaces. So for a size of, just do a bunch of comments. Build out this little table. So for a size of, we had size 5, right? We had 1 space and 2 spaces, right? For a size of 7, we had 3 spaces. For a size of 9, how many spaces do you think we're going to have in the very first row? 4. Okay. Right. So let's check it out. So if we enter another row in here, we do 1, 2, 3, 4, 5, 6, 7, 8, 9. Bump these all over one more. We have 1, 2, 3, 4 spaces. That checks out. Sorry, just checking on chat here. Yep. Oops. Did I not do 9? That's 9. Okay, I was missed one. Sorry. So that's 9. So 9 was 4 spaces. So how can we get from size to spaces? Is there some sort of arithmetic we can do? Turns 5 into 2, 7 into 3, 9 into 4. Integer division, yeah. So 5 divided by 2 as an integer. Yeah, or so if you started lower, we could just keep increasing. But the quick arithmetic is divide by 2 with floor division. Right? Get rid of the decimal place. So then I'll have a number of spaces. Numbers of stars? Oh my goodness. Number of stars. Number of spaces is going to be my size floored divided by 2. So we'll print the space character times the number of spaces plus the star times the number of stars. We'll take our number of stars plus 2, and we'll take our number of spaces minus 1. Take away a space each row. Right? Each row has 1 less space than the row before it. Let's try it. Let's see if we can get an equilateral triangle. Oh, we didn't get odd yet. So to make sure it's odd first, right? So to see if a number is even or odd, right, we can say if my size mod 2, remember Python is truthy, so anything other than 0 is true. So if it's true, we don't want to do anything because it already is odd, right? So really, we want the else here, or we could say if not this, or at that point, just if it equals 0, it's probably easiest here. Because if it equals 0, 0 is false. So you could say not here. I think that's awfully confusing. I'm not a fan of this at all because that just doesn't make a whole lot of sense, right? But we can say, hey, if mod 2 is 0, then we'll take our size plus equal 1. We'll add 1 to it, make sure it's odd. That makes sense? So this is our check for odd. So if it is even, then add 1. Even plus 1 has to be odd. Let's try it. What size triangle do you want? 15. All right. So we get 1, 3, 5, 7, 9, 11, 13, 15. I mean, not exactly equilateral, but relatively close for our ASCII art, right? Here's our right aligned, 15. Here's our left aligned, 15. Right? Not too shabby. We've done squares, we've done rectangles, we've done triangles. I don't think we want to try a circle because it just won't work. Right? We can't really do anything round because we have mostly straight lines here. Does that make sense how we're using the loop? Where'd our code go? So you probably could have done this in a for loop if you wanted here. It'd be a little funny here. And range will do all sorts of other cool things we'll get to later. So range, like you don't have to always go by 1 when you range, but we'll get into that later. So you might see that in some sort of solutions if you look for it here. Right? We okay so far? All right, so we got to talk about the next lab exercise, and then we've got time to work on that and the project. I think that's about all we got for tonight here. Don't forget, check out Dr. Chuck's section on debugging. He's always really helpful here for stuff like that. And if you like his exercises, go for it. Right? He's got solutions for it on the website, which is cool. And if you want extra practice, you can always go to Dr. Chuck. Has anybody been watching his YouTube videos, by the way? I'm just curious. Okay, yeah, it's on Coursera too.
Yeah, oh yeah, I guess it's the same video. Yeah,
I think so. Yep. Yeah, so if you have a Google account too, you can log in and actually like submit the practice exercises and things, and it auto corrects them for you or tells you if you're right or wrong, which is fun. Okay, very cool. Yeah, awesome. So you want to talk about the lab and then we'll take a break? We've been going about another hour again. So you can start on it if you want. If not, you can just leave or take a break after for lab. Okay, so we'll do that. So let me start up a new link here. Nope, that's the wrong button. That's the wrong button. This one here. So this will be our lab 4, CIS 2131, summer 2022, lab 4. Got my Python template. Awesome. Iteration, not iterations. So let's do next week before class starts, 6 p.m., 10 points. In labs, make sure you turn in text here. Set the URL to your UI file. Okay. So we're going to practice doing while loops and for loops. Right? We need both kind of loops here. Okay. So we're going to please write Python code that asks the user to enter a date, month, then day, then year. Validate the month, day, and year are in valid ranges, right? So month is 1 to 12, right? Day is 1 to 31, and then for year, let's make sure it's 2000 to how about 2099 here. How about that? That sound like a valid range? Okay. And then count how many days till that day. So for you, you don't have to do anything silly, like figure out what day it actually is. Hard code in like, hey, it's June 13th, 2022. Actually, so we should go beyond here then, right? So let's say 2023, because we don't want to have to count backwards. That'll make things really weird here. Okay. So we're gonna have to loop, right? Counting the number of days. So get a valid date first, a valid month, a valid day, a valid year. Then count the days until then with a loop. Or do arithmetic if you want to do arithmetic here. I mean, either way is perfectly fine. Right? The year arithmetic is pretty easy, right? 365 per year, right? For every year, up in between. I mean, how about calculate then? How many days until that day? That seem okay? So it'll be some day in the future from January 1st, 2023 up through December 31st, 2099. Figure out how many days until then. Okay. Don't go too crazy here, right? I mean, something more than like times 30 days for every month, because that's not accurate. But you don't need to like account for leap years or any nonsense like that. Like, this shouldn't take you more than like 20 minutes. That's kind of the goal here, okay? So don't go crazy and account for leap years and other nonsense. It's simple. Mostly an estimate is good enough, right? Is that okay? So hopefully you're not freaking out. Dates are really hard, but like it shouldn't be super crazy here, right? Is that okay? All right, awesome. And you don't, because we're getting all these values differently, you don't need to make sure that they're not entering like February 30th. That's okay. If they do that, they're just dumb, and that's on them, not us. Okay? There is no February 30th, but we don't need to worry about that. All right? So we'll just, as long as the month is between 1 and 12, the days between 1 and 31, the years between 2023 and 2029, we'll be okay. Right? So it's not super crazy amount of validation here. Okay? That make sense? Yeah, dates are really hard. It's one of the hardest things in programming is dates, weirdly enough. Because you'd think a lot of things about dates, and they're not always true, especially when you deal with daylight savings time and like time going backwards, and it's just awful. So again, this is a very pared down version here. Okay, that's our for our while loops here essentially. Okay.
We're not allowed to use the date function.
Yeah, don't use the date function. So like we're doing this the cheesy way by hand.
But
Yeah,
we can
thank you.
check that.
Sure. Yeah, if you want to check your work, see if you got close. Yeah, use the date function. This by hand, and by hand is your own calculations. And again, 365 per year, perfect. Don't worry about leap years. If you want to say every 4 years is a leap year, that's fine. But then like if you don't hit the right year and you've added in I don't know, dates are hard.
So would you just do like January 30, if they put in January 15th, you can take 31 minus 15.
Yeah.
And then you'd say February has 28. Then you just add those numbers.
Yeah, you could add them in.
And then you get to the end of the year, and then you just
Yeah, so you probably want to
do
get
the year.
Yeah, you probably want to get to the right year and then figure out how many days are left until you get to that number. Right?
Comparing this number to the,
So from today.
is it the user also entering today?
No, so you can just code in like June 13th, 2022 is today. Or like 6 is June, month is 6, or current month is 6, current day is 13, current year is 2022, that sort of thing. Yep. Okay. So don't like overcomplicate it. Like 20 minutes to half an hour for this, and then call it quits. Okay. Take more than 30 minutes, please. Right. I don't want you ruining your day on this lab. Like it's just looping exercise here. Okay. So that's our while loops, our validation loops, sort of things here. Right. And then for our for loops here, let's go and make a diamond. Actually, we did a while loop with that anyway. Maybe that's not a for loop. That one's no good. So this will be for while loops. Right. While loops. And then for for loops. Let's go and let's see. I had some, I just lost it on my head. It's too much caffeine. So let's display all possible times, hour, minute, second, times in a day. So if you loop for every hour, and you loop for every minute, and you loop for every second, we should be able to print out all the possible clock display times on a digital clock. So you can put a loop inside of a loop. Is how you would do this one. So we didn't actually have to do that with any of these other ones here. I should have shown you that. So let's look at, let's just do one up here real quick. Let's say for tens place in range 10, and then for ones place in range 10. We'll print tens place times 10 plus the ones place. So a loop inside of a loop here, these are called nested loops. So for every time this one runs here, this one will run start to finish. So I'm going to start at 0, right? This is from 0 to 9 here, and this one again is from 0 to 9 here. So when this one starts, tens place will be 0. My ones place will go from 0 to 9. So I'll get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When this one is done, then I go back up to the top and take the next iteration. Then I'll have 1 in my tens place, right? Tens place times 10 plus my ones place. So I should get the numbers 0 to 99 here. Now, this is just a silly example. You could just range from 0 to 90 or 0 to 100, right? Just range 100 if you wanted, but it's a loop inside of a loop here, showing all of those. Does that make sense how you put one inside of another? So you do a similar thing for the clocks. You do hours and then minutes and then seconds. Okay? All right, cool. So let's work on that. And so like 0, 0, like 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 1, right? 0, 1, 0, 0, 0, 0, 01, 00, 01, right? Like all the way up to 23, 59, 59. If you're doing the 24-hour clock, if you want to do a 12-hour clock, that's fine too. I'm just used to these. And then it's easier because you start at 0 instead of starting at 12 and then going to 1. Because why is midnight 12 and then 1 o'clock instead of 0? Because I think the 12-hour clock's dumb. But does that make sense? All right, so just some practice with loops with these here. And then we can also spend more time working on the project, our basic tabletop role-playing game builder. Okay? And I'll post a lab or a quiz for loops in a little while. So we got 10 minutes to take a break, or really as long as you want now. We got the labs and the project for the rest of the night. Okay? Thoughts, questions, concerns? Sweet. All right. For anybody online, hit me up on Discord or send me an email or text me if you want to meet up. Happy to chat. Let me commit this here. So this is chapter 5. Oh my goodness. Chapter 5 examples. What do they do with main? Oh, added in a space. That's fine. Get all that pushed out to Discord, to GitHub, and we can go from there. All right, folks. You take care, and I will see you around.